Procedural generation is the most fun thing. Not even the results it produces, those can be fun too, but the process itself. There's so many different ways of doing it, and they're all super interesting. You can carefully construct tables with probabilities for different events, like a Dungeons and Dragons sourcebook, or you can run a physically realistic simulation of rainfall or plate tectonics, an infinite number of other things. And, notoriously, for people who prefer a more instrumentalized approach to generation, someone just looking at the final results might not even be able to tell the difference. But for me, that instrumentalized approach misses out on procedural generation as an art form in its own right, where the process itself is the goal. Anyway, all that aside, today I'm going to talk about the procedural generation system for my game, which is neither a work of art nor producing particularly interesting output by normal standards of procedural generation, but it is, I think, well suited to this particular project with its somewhat odd needs. If you're new, this is the devlog for a game that tries to capture the unreasonable excitement of writing a little simulation and watching the little simulated agents live out their little simulated lives. But, as a game. The player controls a group of characters who explore the world and its dungeons, collecting loot, rather than focusing on manually controlling each character or high-level management of pre-made AI characters. The game is about designing the behaviors of individual characters directly using Python, or for the truly adventurous, other languages like Rust, via a low-level WebAssembly API. In some games, like big open worlds, the focus of procedural generation is on filling the gaps around hand-generated content, just because making such a huge world by hand would be far too much labor. But in others, like roguelikes, the goal is to make much smaller worlds, which are different enough each time they're generated that they're fun to replay. This game is more like the latter than the former. The world is very small, but the requirements for replayability are a bit different than a normal roguelike. The player can take direct control over a character and explore the world, and I do want that experience to be compelling, but it isn't the main play mode. The main play mode is fully AI-controlled characters. With that in mind, the goal of procedural generation isn't to produce extreme novelty, but rather subtle variation, which requires the player to design flexible behaviors and enlarges the space of interesting strategies. Having a generator that produces worlds which are so different from session to session that only a human equivalent AI would be smart enough to play them all effectively might be interesting for a game where the characters are controlled by the player directly, but not when designing AI is the game. Designing behaviors is already hard enough when the situation it has to deal with is highly constrained. So the generator needs to be subtle but interesting. Like Brian Eno's ideal ambient music. It should be as ignorable as it is interesting. Alright, so that's my requirement. Subtle but interesting. But that is, it's a bit broad. So, more specifically, I want the world to have one of a small set of basic topologies. Currently there are 2 variations for the main world. And within each of those, the basic resources and obstacles are arranged randomly each session, but with some constraints always being respected. Like, there must always be a traversable path between the player spawn point and the central goal of the level. So the generator needs to first make a large decision about which topology to use, then progressively place obstacles, spawners, and resources, assuring that the constraints for each are met. But it may be possible for the early decisions to produce layouts which are impossible to complete later. For instance, if obstacle placement doesn't leave enough free space for all of the spawners. That means the system needs to be able to backtrack and redo those early decisions if it hits a dead end. I'm implementing this as a directed acyclic graph, like this one, where each node represents a decision the generator needs to make and a constraint it must enforce. Branches represent alternatives which the generator can choose between. If a constraint fails, then the node will retry its decision until a number of retries is exhausted, at which point it will move back to the previous node, retry that one until its retries are exhausted. If it gets all the way back to the root, generation has failed. If, on the other hand, it reaches a leaf node, generation has succeeded and produced a usable layout. Different graphs can produce dramatically different levels. For example, this is the graph for the dungeon generator and its output. The dungeons are much different from the main world, and that is entirely because of the different configuration used by the generator. To ease experimentation, the graphs are defined via configuration files like this one. This lets me quickly change the generator or add new generators for new levels, and could be used by modders to customize the game. Alright, I could talk about procedural generation forever, but that's all I have to say about this particular system right now. I'll be continuing to expand and refine this as the game develops, so there will likely be future videos about it. So if you're interested, do subscribe to see those. And if you'd like a more in-depth look about the details of this particular generator, do let me know in the comments and I will do that. If you've made it this far, you're probably interested in the game, so you might want to swing by the Discord where there's a playtestable demo available. People trying out the build help the project immensely by finding bugs and providing feedback, but also can guide development in other ways, like how important is the visual programming system I've talked about in previous videos? Should that be a core part of the game, or should I focus on the API for Python and Rust and worry about providing a more game-like interface for less experienced developers later? Anyway, thank you for watching, and I hope you'll join me next time for more progress on the game.